Good morning. It's 11:30. Get started. Um, no one in the video call right now, but on we go. Share my screen and we'll get started here. So I will invite you to ask any questions from last time or any of the times before. Obviously, this is all, we're building a little building here that the lower floors are very important for. The foundation we've already been laying is incredibly important as we start putting more things on top. Actually, I guess you could say this whole thing is a foundation, and we continue to make it firm. Don't forget, you can text me. I'm gonna move things around here a little bit so I can write on the screen a little bit better. So anyway, you can certainly send me texts. That would be fine. Hi, Tracy. Good to have you in here. Okay. So just reminding everybody about the fact that you can text me. As you know, today it's Trig 5. A lot of what I'm going to be doing today is going to be a repeat. We continue to build this foundation. I'm anxious to hear any questions you have. Some important things we need, hopefully you have nailed, are the ability to come up with these angles like we did a few lessons ago. Not the dotted ones, but all the other ones. And in terms of pi, the red figures up there, not the blue. The blue are important too, but so you need to be able to come up with those angles. On the quizzes, you'll see how they'll be continually asking you about that. And then the other really big foundation piece are the two special right triangles. The isosceles right triangle, which is on the bottom, where the two legs are of equal length, which I've labeled 1 here, and then using the Pythagorean theorem, as I did at the right, you can find the length of the hypotenuse. And then the 30, 60, 90 triangle, right triangle on the top left, where the side opposite the 30-degree angle is half of the hypotenuse. So those is 1 and 2. You could use, by the way, 3 and 6, 2 and 4, anything that's half. But to make the ratios as simple as possible, you want to have one side be 1. It'll just save you simplifying fractions later on. Yeah, and let me erase here. It might be a little, well, yeah, I originally called this side X here, but anyway, yeah, if that side is X, using the Pythagorean theorem, you can find that that leg turns out to be the square root of 3. Well, now that you have that, what do we have here in this picture? We've got the sine, cosine, and tangent of 3 special angles, 30, 45, and 60. And they were part of the last quiz, kind of the root of the last quiz, and will continue to be the foundation as we expand that chart. So the outline, kind of where I wanted to go today. We'll see how far we get, but we've already looked at the behavior charts, but I want to look at them again and make sure, hopefully, you get what those behavior charts are trying to show you. And then we're going to apply that when we come down here. And as we get to these other special angles in new quadrants, we can use our root behavior charts in order to come up with not only the proper ratio, but the proper SIGN. If we have time, we'll get into 6, 7, where we just a reminder of what negative angles are, what happens when you go more than 360 degrees, and I don't know if we're going to get to 8 or 9. Probably not. So let's start with, once again, taking a look at the behavior charts. First, the sine behavior chart. The sine behavior chart, we're looking at the vertical leg of the right triangle that rotates around. What I have highlighted in dark blue here, or bright blue. That's the leg we want to keep our eye on. So as this triangle starts off in the down, in a real low position, like let's say approximately like that, this vertical leg is really tiny. And as we start moving and making the angle bigger, the leg continues to get bigger. So where did it begin? At 0 degrees, the sine was 0. It's increasing, as we see in this note up here in the top right. And because it's up, the first quadrant has all positives. We're getting higher and higher and higher. And when we get to this vertical position, we actually don't triangle, but we can see the height of that is full height. And in our unit circle, the sine of 90 degrees is 1. Then, as we start moving over into the second quadrant, our triangles look, now they're over here on the left, and you can see that the vertical leg, as we move on, is going to get smaller and smaller. So we see we have decreasing, but still above, so it's still positive. When we get down in the third quadrant, oh, and I should have said, what happens when we get all the way over here into the 180 position? Of course, the triangle has shrunken down and is flat and it has no vertical coordinate, so it's 0. Then when we get in the third quadrant, we've got triangles that look like this as they're moving around. I'm just trying to do a variety of them here. And you can see as we keep moving, that vertical coordinate, first of all, is below, so it's negative, as indicated down here on the left. And it's getting negatively bigger, which means negatively bigger means decreasing, right? Negative 1/2, negative 0.8, negative 0.9. And at the max, it gets down to negative 1. And then, I guess you could say the opposite occurs. As we get fourth quadrant, the vertical leg that's negative is getting shorter, and smaller negatives means we're increasing. And eventually, when we come up all the way, we get real close here to back up to the complete rotation. It's negative, real tiny, and finally it collapses, becomes 0, and the whole parade begins again. So overall, note this about the sine. Positive in the first and the second quadrant, negative in the third and the fourth. Why? Sine is a vertical coordinate. When you're above the x-axis, it's going to be positive. When you're below the x-axis, it's going to be negative. It's increasing whenever you're to the right side, the fourth and the first quadrant, and it's decreasing whenever you're on the left side, second and third quadrant. Okay, cosine. So the cosine is a horizontal guy. It's this, this blue segment, it's the bottom leg, the horizontal leg of the right triangles. And so when the triangle is stretched and has just a tiny angle, like maybe this, you can see that the horizontal leg is pretty long and it goes almost out. In fact, as soon as it's 0, it goes full width, and the cosine of 0 degrees is 1. As we move up, you can see what's going to happen here. This leg is going to start getting shorter. So we see we have decreasing. And yet, because it's cosine horizontal measurement, whenever you're on the right side of the y-axis, you're going to have a positive. So you see these two positives here, both in the first and the fourth quadrants. And when you're on the left side of the y-axis, you're going to have negatives. So this cosine in the first quadrant, as you move up, is going to get shorter and shorter, and finally it's going to, when you get up to 90 degrees, it shrinks to nothing, and that's why the cosine of 90 degrees is 0. And then as we move over here, now our triangle looks like this, and just red here, this now becomes the horizontal coordinate, and because it's left, it's negative. And it's what? It's going to start getting bigger negatively. What do I mean by bigger negatively? A higher number with a negative on it, which means it's decreasing. And eventually it's stretched out to the full width left. So -1 over here at 180. And yeah, I'll just do 1 down here in this quadrant. So the horizontal coordinate is still left when we're in a third quadrant position. And now as we move forward in this direction, it's going to start getting shorter negatively. So it's increasing, and eventually it shrinks to nothing when we're down here at 270. And then it's going to start getting positive. Tiny, but to the right, so positive. And it's going to get bigger, 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 and finally it'll reach full width, and we're back to 1 again. So summary of the cosine. Horizontal guy, whenever it's to the right, it's positive. Whenever it's to the left of the y-axis, it's negative. It's increasing this time in the third and the fourth quadrant, just the opposite of the sine, and it's decreasing in the first and the second quadrant. And then I called it kind of the strange one, and it may be a little bit harder to see because this time, as you know from geometry, a tangent line is a line outside of the circle which just barely touches the circle in one point, which would be right there. This line that I've pointed to in blue, that's the tangent line, this one right here. That's the tangent line. And here's the point of tangency where I've marked it there. Okay, so now as you make your angle, we have to extend this hypotenuse out until it hits the tangent line. And then the distance from where it hits, back from the 0 line, that's the measurement of the tangent. So the tangent measurement is always a vertical distance. And if it's up like it is here, then it's positive. Okay, so we take a bigger angle, let's say this, and it's going to take more work to get it, you know, it's going to probably hit the tangent line up there. We still have a right triangle, but now you notice the tangent has what? Doubled. It's twice as tall as it was. Now it goes all the way from 0 up to here. So the tangent is increasing big time. If we made an angle like this, we would have to go way off the page before it hit the tangent line. The tangent's going to get huge. And in class yesterday, we were doing tangent of 89, tangent of 89.9 degrees, tangent of 89.99. And the closer you get to 90, the tangent just takes off like a rocket. As soon as you hit 90, of course, this line, this vertical line at the y-axis is never going to be what? It's never going to hit the tangent line. It's parallel. And that's why at 90 degrees and at 270, we're vertical like that, there's no answer. And we use UND to represent undefined. So a little different thing happens in the second quadrant. We take an angle, sorry, hard to draw straight. We'll have an angle that'll look something like that. And of course, going out this way, it's never going to hit the tangent line over here on the right. So what we have to do is back it up. And it'll hit down here. So now the tangent changed to green here. Now the tangent goes from there downward until there. And so now we have a negative tangent. So that's why second quadrant has a negative by it. When you come back to the third quadrant, now you draw your angle. Well, this is not going to hit the tangent line on the right, but when we back it up, it will, and it's going to be above. So it'll be a positive. Fourth quadrant, it goes downward, so we're back to negative again. So, and maybe the strangest thing of all is you notice all four quadrants, the tangent is increasing. So how can it keep increasing and yet repeat when it gets past 360 degrees? And the answer is it does this disappearing act, this undefined, when it reaches 90 or 270. All right, so now what I started in class yesterday was filling out this expanded chart. I've now changed it a little bit, and I put the two missing angles, 330 and 360, I've stuck them down here to the right. So I want to go through this process with you one more time. This is so important that you be able to do this. So first of all, down here on the bottom left, I have put a couple right triangles down here. This over here is pretty obviously the isosceles right triangle. And I don't know if you remember, with a little bit of Pythagorean theorem, we can find the hypotenuse is the square root of 2. Here, this is the 60, this is the 30 degree angle. The side opposite the 30 is half of the hypotenuse. And then using the Pythagorean theorem, we can find that missing leg. So that became the root for filling out what was in the red box in our chart here. So if we start with 30 degrees, what's the sine of 30? Opposite over hypotenuse, that would be 1/2. 45 degrees, these are both 45s here. And by the way, it doesn't matter which 45 you do it on. But what's the sine of 45? Opposite over hypotenuse, so it's 1 over the square root of 2. What's the sine of 60? Sine of 60, opposite over hypotenuse, square root of 3 over 2. Okay. Maybe what I should do is, instead of going sideways, down. So let's do the other 30 degree one. What's the cosine of 30? So back over here, leg adjacent, square root of 3 divided by hypotenuse, square root of 3 over 2. And what's the tangent of 30? Opposite over adjacent, 1 over the square root of 3. Okay, 45, we're back over here. What's the cosine of 45? Leg adjacent over hypotenuse. You notice that the odd thing about 45 degrees is the sine and cosine of 45 are always the same. That's because two of the legs are identical. And what's the tangent of 45? Opposite over adjacent, 1 over 1, which is, of course, 1. 60 degrees, cosine of 60, leg in this triangle, leg adjacent over hypotenuse, 1/2. And tangent of 60, opposite over adjacent, square root of 3 over 1, square root of 3. So there's that previous quiz. Okay, so hopefully You guys have nailed that. You know what? Before we go any further, why don't let's do all the angles. You see how I have the degrees filled out, but I have left the radians blank. So here's where we got to practice our ability to think in terms of radians. So you could either call this 0 or 2 pi, it doesn't matter. 30 degrees, do you remember? That's actually what? If you're doing the 24th things, that's, 24 equal chunks. That would actually be 2 24ths or 1/12 of 2 pi, which is pi over 6. 45 was pi over 4. 60 is pi over 3. 90 is pi over 2. Then 120 is really what? Double 60 degrees. So what if 60 is pi over 3, isn't 120 2 pi over 3? 135 is what? 45 degrees past 90. Okay. So, I mean, isn't that really just 45 3 times? So what's 3 times pi over 4? 3 pi over 4. And then 150, let's see. 150 is what? Well, 180 is a full pi. Let's put that down. And we're what? 30 degrees less than that. So we're just 1/6 pi less than 1 pi. So that'd be 5/6 pi. 5 pi over 6. So I'm going at this a little differently. I'm just trying to show you some other options here. Okay. Isn't 210 just 30 degrees past pi? So pi over 6 past pi. So 1 pi plus 1/6 of pi would be 7 pi over 6. 225 is what? Pi over 4 past 1 pi. So 1 1/4. 5 pi over 4. 240 is what? 60 degrees past pi. What's 60 degrees? Pi over 3. So what's pi plus pi over 3? 1 1/3 pi. 4 pi over 3. 270, that's what? Just 1.5 times, each halfway around is pi. All the way around is 2 pi. What's halfway between pi and 2 pi? 1.5 pi. 3 pi over 2. 300, I'm going to go at it the backwards way now. 300 is what? 60 degrees short of going all the way around. All the way around is 2 pi. 60 degrees is pi over 3. So what's 2 pi minus 1/3 of pi? Wouldn't that be 1 2/3 pi? So 5 pi over 3. 315 is what? Just 45 degrees short of 2 pi. So 1/4 pi less than 2 pi would be 1 3/4 pi. 1 3/4 pi. And then 330 is what? 30 degrees short of all the way around. 30 degrees is 1/6 pi. So what's 1/6 pi taken from 2 pi? 1 5/6 pi. And finally, 360, of course, is just you can either write that as or pi. So I was just a little different way of going at the angles, but hopefully that makes sense. So now let's see if we can use our behavior charts to fill in the rest of this thing. Sine, remember, that's the vertical coordinate. At 0 degrees, the vertical coordinate is shrunk to nothing. So that's got to be 0. Let's keep going with sine. What's the sine of 90? The triangle is all the way up to the top, so the sine is full height. Okay, so what do we do? And maybe we should do 180, we're back to 0. 270, we're full down. And 360, we're full up. So I'm just sticking in the quadrantals. All right, what about the sine of 120? At 120, what's the angle, what's the nearest angle to the x-axis? 60 degrees, right? And what's the sine of 60? We've got it right here, square root of 3 over 2. How about the SIGN? Sine is still up in the second quadrant, so it's positive. 135, isn't that just a 45-degree angle with the nearest x-axis? What's the sine of 45? 1 over the square root of 2. Again, we're up, so it's positive. 150 degrees, that's what? A 30-degree angle with the nearest x-axis. Sine of 30 is 1/2. We're still up, so it's still positive. 10, that makes a 30-degree angle with the nearest x-axis too. The only problem is it's down. So anyway, it's 30 degrees. Sine of 30 is 1/2. But because we are now below, and sine is a vertical guy, this has to be negative 1/2. 225, 45 degrees back up to the x-axis. The sine of 45 is 1 over the square root of 2. We're down, so it's got to be negative. 240, 60 degrees from the nearest x-axis. The sine of 60 is square root of 3 over 2. We are down, so this must be negative. Okay, how about 300? What's the nearest x-axis? It goes up to the 360, so that's 60 degrees. The sine of 60 is the square root of 3 over 2. Is the square root of 3 over, sorry about that extra mark in there, square root of 3 over 2. Now, we're still down though, aren't we? We're down below the x-axis, so this has to be negative. So that, here, let me try writing that again. By the way, what I'm having trouble with here, and I'm gonna see if I can just move things a little bit so I don't lean in the wrong spot. Let's see. No, that's not what I wanted. Whoops. Oh my. My apologies. I lost something here. There we go. I may have to reshare this. I do. I see you're not seeing me now. So let me just go back and reshare, hopefully. Yeah, you guys hopefully back on now. And what I wanted to do is just clean up this last entry. So that should be what? Minus 3 times the square root of 2. I'm sorry, minus the square root of 3 over 2. Okay, and 315 is what? 45 degrees from being all the way up. What's the sine of 45? 1 over the square root of 2. We are still what? Down. So it's got to be a negative. And finally, 330, down here on the bottom now. 330 is 30 degrees from the nearest x-axis. The sine of 30 is 1/2. We are still down, so this has to be a negative. Again, my pen created an extra mark there that reads negative 1/2. Okay, let's go back and do cosine now. Cosine, remember, is a horizontal guy. And when you start at 0 degrees, it's full width right. So it's going to be a full 1. All right, when we get to 90 degrees, the horizontal coordinate has shrunken down to nothing. Let's do the other quadrantals. What happens when you get to 180? Now we're full to the left. And because we're doing left-right, left is negative. How about 270? Back shrunk to 0 again. And how about 360? We're just back where we started at 1. Okay. Now, filling in at, let's pick it up at 120 degrees. Nearest x-axis, 60 degrees away is 60 degrees. What's the cosine of 60? Just look in the box. It's 1/2. Is it positive or negative? Because we're to the right yet. No, I'm sorry. We're to the left now. That has to be a negative, right? 120. We're just into the second quadrant. 135 is what? 45 degrees from 180. That's 1 over the square root of 2. Just copied from inside our red rectangle, but because left, negative. 150 is 30 degrees from 180. The cosine of 30 is square root 3 over 2. Because we're still left, it's negative. Okay, 210. 30 degrees past 180, so we're back to this 30-degree thing, square root of 3 over 2. And we are still left. We're down in the third quadrant now, but we're to the left of the y-axis. Remember, cosine is a left-right guy. Okay, 225 is a 45-degree angle. That's 1 over the square root of 2. And we're left, so it has to be negative. 240 is 60 degrees from the nearest x-axis. The cosine of 60 is 1/2, and we are still left. And then when we get to 270, we already know it shrinks down to nothing. Now we're going to go into the fourth quadrant. We're to the right now, so these should all be positive. So first of all, we have what? 300? Okay, 300 is what? 60 degrees from the nearest x-axis. The cosine of 60 is 1/2. Because we're to the right, this stays positive. 315 is 45 degrees from 360. And so cosine 45 is 1 over the square root of 2. And again, we're right, so it's positive. And finally, 330 degrees is 30 degrees from the nearest x-axis. The cosine of 30 is the square root of 3 over 2. And again, we're to the right, so it's positive. So we have completed cosine. Now let's go back and get the tangent. Let's see, that 1 is still bothering me in the cosine blank, so I'm going to just redo that. Oh my. Let's see if I got rid of that line I've just introduced there. Oh my. Okay. Hang on, I'm in a weird spot here. There we go. Yeah, I've got some strange writing going on. My apologies for that. Anyway, I'm trying to undo that, and it's not wanting to do it. Wow. Okay, let me try undoing those. Nope, they don't want to go away either. No, I can't even erase. Okay, so let me talk through the tangent. By the way, I have another slide here. Maybe I should just go to that. Yeah, here's our way out. This is completed from another year. So if you look at the tangent now, remember, the tangent is how high we meet the tangent line out to the right. At 0 degrees, we're not going to be up at all, so that's a 0. How about at 90? That's the undefined. What happens at 180? Figuring, I'm just going and doing more of the quadrantal angles. At 180, the tangent's going to be, when you back it up, we'll meet it at the 0 point, so it's going to be 0 again. How about at 270? We're parallel to the tangent line off to the right, so that's going to be a UND. And at 3C, well, we're right where we started at 0. Okay, so now that means we got to pick it up at right here, arrow drawn there. Hopefully you can see that. We're going to pick it up at 120 degrees. 120 is, what's the nearest x-axis? 60. What's the tangent of 60? Square root of 3. Why is it negative? Because we're in the second quadrant, I have to back it down, back it up, and go down, and so it's going to meet the tangent line off to the right below. Hopefully you can see that in your little projector in your mind. Okay, 135, the nearest x-axis is 45 degrees. We already know the tangent of 45 from the box is 1. Why is it negative? Because we're in the second quadrant. We got to back it up so it goes down below again. 150 is 30. Same as in the box, 1 over the square root of 3, negative because of that backing up again. Finally, we're back up to 0. So at 210, we're 30 degrees what? Past. So 30 degrees, tangent of 30, look in the box, 1 over the square root of 3. Why is this one positive? Because in the third quadrant, when you back it up, it winds up hitting a tangent line above. So we're positive again. 225, well, that's a 45-degree angle. We know the tangent of 45 is 1. It's positive because when we back it up, we wind up on top. And 240, that's what? A 60-degree angle. So tangent of 60, square root of 3, positive because, again, we back it up and we come up on top. But when we get down to 260, now we're going to have that parallel. It's never going to hit that tangent line off to the right, so we have to write undefined. Well, I guess we already had that. 300 degrees. 60 degrees from the nearest x-axis. Tangent of 60 is square root of 3. Why is it negative? Because now we're in the fourth quadrant, and when we extend it, it's going to hit the tangent line below the x-axis, negative. 315 is 45 degrees, so we know it's 1, negative, because fourth quadrant, it extends downward. And the last one, 330, that's, of course, 30 degrees away. So 30 degrees, tangent of 30 is 1 over the square root of 3. Fourth quadrant, so when we extend it down, it's going to be below. So there is probably your next quiz right here. Can you do this? I'm sure you can, but it all, you know, some of you had a little trouble the other day when we were doing the red rectangle part. There's all kinds of pitfalls here, right? Remember, if you get your SIGN wrong, I have to mark that entry wrong. A problem, now this particular quiz is going to have a lot of points because there's a lot of boxes we filled in, right? So, but still, there's all kinds of things you could goof up on here. You've got to have those SIGNs right. And you've got to, what, have tucked away in your head how those behavior charts work. All of that kind of has to be in your head. So let's open it up to questions. Again, is there any part of this that either what, maybe I misspoke, or you're not understanding my strange way of describing this, or whatever it is, I'd be happy to try to clarify. Remember, you can send me a text message, 262-510-2046, or an email, or a phone call, whatever works for you. Questions? Tracy, I see you're on there. Did you have any?
No.
Okay, you're still there. That's good.
Yep.
So did you like my strange drawing of black lines all over the place? Looked like I was a bad kindergartner?
Yeah.
Good thing I had this backup page we could go to, because it wouldn't even let me erase it. So it was kind of weird. Any questions out there? Okay, so here's a kind of an odd situation. You guys all know what your quiz is going to be. I mean, I might throw in something like what makes trigonometry possible. That's not, but I mean, this would be the main meat of the quiz. And this, I need everybody to get this. Another option, if you're still hung up or you don't get my strange approach to this, you can certainly come in and see me. Remember, on Wednesdays, Monday, Wednesdays, and Fridays, I'm there at 7:30 up until our class. I mean, except for chapel, you should be able to get a hold of me. That's an option that might work. So Thanks for tuning in. Send me questions. I'm not getting any, so I'm going to go ahead and sign off. Thank you. I appreciate your attendance.